So today, myself is Dr N GANESH. I work as a Dean and Professor in the Department of Computer Science Engineering, VEL TECH MULTI TECH, Dr Engineering College, Avadi, Chennai. So today, we will be discussing a topic about algorithms and the problem solving using algorithms. So now, before we start, what is an algorithm? An algorithm, it was created or it was derived from the Persian mathematician by name Al-Khawarizmi. So it is by and large, it has been called as algorithmus, and in Latin, which is nothing but it's an algorithm. Now, what is an algorithm? What is the definition of an algorithm? An algorithm, it is a well-defined computational procedure which consists of a set of instructions that take some values or a set of values as input and some other value, or again a set of values as output. It gives an output. So here when we see, you have an input and that input is being fetched to the algorithm, and then it processes and it gives out a set of output. Right. Now let us see the characteristics that determine an algorithm. What are the characteristics? First point is about precision. It should be precise. An algorithm should be precise, that is, it should be specifically defined. The steps have to be specifically stated or it should be defined. Second is the uniqueness. Uniqueness denotes whatever you write, it should be unique. That is, whatever is defined, it should be uniquely defined. Third is finiteness. It should be finite. That is, it should have, an algorithm should have only a set of instructions, only a sequence of set of steps. So it should have a starting point, it should have an ending point. It should start, an algorithm should start and it should stop at a specific period. That is called finiteness. Fourth point is about the effectiveness. What is effectiveness? It should be effective. It should be stern. It should be stubborn. It should be more effective, and it should be the best to solve a particular problem. Right? And the fifth point is input. Any algorithm, as I said, it should get certain input. Sixth is output. It should produce certain output. Then the seventh one is generality. An algorithm that has been written, it should not be specific to a particular point. It should be general. It should work for a set of values. Whatever input that you give, it should give some output. It should not be specific to one particular problem. It should be general. But again, let us summarize. It should be precise, it should be unique, it should be finite, it should be effective, and it should get an input to produce an output, and it should be generic in nature. So this is about the characteristics of an algorithm. Next, let us see about the building blocks of an algorithm. As far as the building blocks of an algorithm is concerned, the algorithm is being classified into four different blocks. First one is the instruction, second one is state, third one is the control flow, fourth one is functions. What is instruction? Instruction is a single operation that describes the computation. When it executed, it converts from one state to another. So, say for example, if you want to add two numbers, you give add A and B and you store the value in C. Right? You are instructing the computer to add, to make some addition between two different variables A and B. So that is said to be an instruction. Second point is about the state. So state is, it depends on the stored data. Right? Say for example, in the same example, you want to add two numbers A and B, and if you want to store it in the variable C. At the first instance, if I am going to give it as the input of A as 3 and the input of B as 5, what will be the output of C? The C will be getting the stored value as 8, because 3 plus 5 becomes 8. And at the second instance, if we are going to give the value of A as 2 and B as 5, what will be the output? The output becomes 2 plus 5 becomes 7. So the value of the state changes. So that is about the state. So the stored data in the algorithm are stored in variables and functions. The state shows the current value or the content. Then the third building block is about the control flow and about the function. Control flow. The control flow is divided, it's classified into three different types. One is sequencing, second one selection, third one is iteration. What is sequencing? The sequencing is, take for example, I have a car and I have a big road, and in front of the road, the road is very clear. I want to drive my vehicle. So how do I drive it? What do? I just put on the gears, I just press the first gear and then I move on, right? Press the accelerator, release the clutch and move on. Then press the second gear, put the second gear, then move on. Put the third gear, move on. Put the fourth gear, move on. Put the fifth gear, move on. Then stop, right? That is called sequencing. So here, if I want to move from one particular position to a different location, I use a sequence of steps, a set of steps, right? So from starting from first gear to move on to the fifth gear, first gear, second gear, third gear, fourth gear, fifth gear, and then stop. So that is called sequencing. Second point is about the selection. What is selection? Say for example, again let us consider the example of the car driving. So when I am driving the car, supposing at the intermediate, if I encounter a signal, I suppose most of you would have driven your car and you know about the signals. You have three different lights: red, yellow, and green. So supposing if when I am driving, if I am going to get a yellow light, what does it mean? It is called as an amber light. So as a driver, I need to decide whether to stop the car or whether to proceed, whether to cross the signal, right? So the decision making is called as a selection, right? The third one is about the iteration. Iteration is a sequence of steps, so it will be followed until the condition becomes true. Fine? So here, iteration is again, let us take the example of a car. You have a signal, you have stopped your car in front of the signal wherein the red line is being shown. And supposing if you get a call from someone and if you are using your mobile or if you are going to text something, the message. So when you are texting, you will be monitored or you will be checking whether the lights are turned green. Supposing the lights are turned green, you will be keeping your mobile aside and then you will be moving ahead. So till your lights get green, you will be doing some other operation of checking your mobile, typing something, right? So you are doing an iterative process. You are checking the signal, you are checking your mobile, checking your mobile, checking your signal. So you are doing it again and again till the signal becomes green. So this is called as iteration. So doing the same operation till the condition becomes true. Fine. So next building block of an algorithm is called as the functions. So what is a function? Function is, say for example, you have a very different program, right? You want to segregate, you want to simplify these concepts, and then you want to put it into small modules. So putting it into smaller and simpler function is called as a function, right? You have a large set of steps and you segregate, you simplify it, and putting it into smaller steps, you call it as functions. So this is about the building blocks of an algorithm. Next one we will deal with the notations of an algorithm. What are the notations? The notations are classified into four different types. First one is the step form, second one is the pseudocode, third one is the flowchart, fourth one is the programming language. What is a step form? A step form is nothing but it is a step-by-step execution of a process. So a step form usually it begins with the symbol called begin and it ends with a symbol called begin. Or begin, or you can use it as start, and you can use end or it ends with a symbol called stop. Fine. So after that you will be including variables and their usage. The third point is if you have loops, you will be giving some step numbers. So the step numbers for when you are going to use it as step form. What is a step form? Again, when you take the example of a car, driving a car in a sequential way, you are applying first gear, second gear, third gear. So step 1, apply first gear. Take your accelerator, press your accelerator, release your clutch. Right? Step 2, apply second gear. So you have steps. And the loop is where you will be doing an iterative process. As I said, I gave you an example with respect to checking your mobile and then checking the signal lights, right? So it's an iterative process that you can give these sub numbers as step 5. Say for example, step 5.1, step 5.2, step 5.3, so on and so forth, right? And you can use jump statement. If you want to jump from one particular location, if I gave an example with respect to, you have an amber light and yellow light blowing, and you need to take a decision call whether to stop my car or whether to move ahead. So if you're going to move ahead, I will be jumping to one particular location. If you're going to stop, I will be jumping to one other location. That is called jump statement. And the unwanted data should not be used when you are writing an algorithm. And the expressions has to be defined precisely. And then the last point is, any algorithm when you are going to start, it should end with a stop. So you can use break and stop. Break is an intermediary termination. That is, say for example, again, if I'm going to drive a car for a long journey, and supposing if I'm going to feel hungry, I will be braking at one particular point, I will be having my snacks or tiffin, and then again restarting my car. Right? That is called break, a temporary stop. But you have not reached the destination. That is called break. Whereas stop is, you have reached the end point, you have reached the destination. That is stop. So this is to be used as a step form. The second notation is the example. Let us take an example for a step form. Say for example, if you want to calculate or if you want to find biggest of three different numbers, how do I do? Say for example, if I have the value of, if I store the value of, if I have three different values, A, B and C, if I store it in variables A, B and C, in A if I'm going to have the value as 5, B if I'm going to have the value of 3, C if I'm going to have the value of 8, then if I want to find which is to be my biggest number. So how do I do it here? Here, this is an example of a step form. Here, the step 1, I do start. Step 2, I read the three numbers A, B and C, 5, 3 and 8. Step 3, I'm comparing the values of A, B and C. So how do I compare? I can compare only with two different inputs. So first I will be checking if A is greater than B. If it is greater, then I need to check it as if A is greater than C. If again, if A is greater than C, I am supposed to print the value of A as the greatest number or the biggest number. If else, if A is not greater than B, then I need to check with if B is greater than C. Suppose if B is greater than C, I need to print as B is greater than C. Or else, if both the condition fails, then I need to print as C is the greatest. So this is what is explained over here. Step 1 is start. Step 2, read the three numbers of A, B and C. Step 3, you compare A and B. If A is greater than B, then perform step 4, else perform step 5. What step 4? I do not know. The step 4 is being given here. Step 4 is you compare again A and C, and if A is greater, you type the output as A is greater. Else you type the output as C is greater. Then you go to step 6. What is step 6 is stop. So supposing if the A is greater, we will be performing if otherwise we will be performing step 5. What is step 5? Step 5 is you compare B and C. If B is greater, then print output B is greater. Else print output C is greater. Then you go to step 6. Step 6 is stop. Here, in this case, the first two steps are said to be in sequence order, because any algorithm, any step form, it should have a start, right? And then the second step will be you need to read the inputs. And step 3, 4, 5 uses the selection logic. Selection logic is, it is making a decision. If A is greater than B, then A should be printed, or else B should be printed. So that is called the selection logic. So 1 and 2 demarcates the sequence logic, 3, 4, 5 step demarcates the selection logic. Next, so the next building block, next notation of an algorithm is about the pseudocode. What is pseudocode? What do you mean by pseudo? Pseudo means false. So it is a replica of the real code. So it is a false code, but it has a replica of the real code. So it is a generic English-like language, written in English-like language, and you have a set of, here in pseudocode you have it uses a set of keywords and the rules are somewhat structured. Right? It is similar to a program code. Let us see an example of pseudocode. First of all, let us see the guidelines of writing a pseudocode. So, for writing a pseudocode, it should begin with the main program. And supposing we have a subprogram or procedures or the functions, we are going to write some procedures. or function, it should have a begin subprogram. So let us begin with the main program. So it should have a begin main program. If you are going to have a begin main program, you are supposed to have an end. As I said, if you have start, you need to have stop. So begin main program, at the end you will be having end main program. Nowadays people simplify it and they write it as begin and end. So second one, there an algorithm in step form you wrote it as read ABC, read the input values of ABC. Here instead of what you are supposed to write as initialize A, B and C. So then you are ending the initialization. Then for subprograms you are supposed to write it as begin subprogram and end subprogram, as I said. For selection you are supposed to write it as if, then, else, and when you are going to start with if, here in pseudocode you are supposed to end the if with a keyword called endif. We have started if, so it should be ended with endif. And for multi-way selection, if it is of case, you can use where. And when you are using in case, you are supposed to end it with an end case. When you are going to use the while statement, while is a looping format. It is called as a entry criterion loop. Entry criterion loop is, it will be checked, the input will be checked prior and then it will be going into the loop. Right? When you have while, it should be ended with an end while. And for post test, it should be used like repeat until, repeat till the condition fails. Right? Repeat until. So, and for easier understanding, for easier recognition, the keywords, whatever we type, we write, it should be written in capital letter, so that demarcates between a keyword and a generic statement. Right? It should be written in capital letter, and it should be indented. Whatever we write, it should have an indentation just to have a look and feel effect. And when you are going to have a subprogram, say for example, add is to be a subprogram. So the name of the subprogram, it should be underlined. So these are some of the guidelines for writing a pseudocode. Next, let us see about the third notation of an algorithm, which is said to be a flowchart. What is a flowchart? A flowchart is a diagrammatic method of representing an algorithm. So what do you mean by diagrammatic method? So whatever we write, whatever we code, when you see a diagram, a picture is worth 1,000 words. So when we see a diagram, we can understand, we can easily recognize. So this flowchart fulfills the purpose. So flowchart is a diagrammatic method of representing an algorithm. So here in the flowchart, we will see certain flowchart diagrams. These are certain symbols used in the flowchart. We have an arrow bar which demarcates the flow line. Flow line is the arrow or it is a connector. So it connects between two different processes. So next symbol is the oval symbol, the ellipse symbol, which is called as the starting stop, or it is called as a terminator symbol. The third one is about the data symbol, where here only this is the parallelogram symbol. In this symbol only we will be using it to get the input. The fourth one is the document symbol. It will be of this format. So this is used to document your work. Fifth one is the process. Say for example, as I said, add C equal to or C equal to A plus B. The C equal to A plus B has to be written in this, the procedure or the process. So that comes with the rectangle symbol. Then the diagonal symbol is used for the decision making, which is said to be the selection logic. The round symbol is said to be the connector. If you have the flowchart written in 2 or 3 different pages, and if you want to connect from one different page to the other different page, so I use a connector. It shows the connectivity. That shows the round. The next set is, this is a box type, a box present within a box is called as a predefined process, or it is used for subroutine or for procedure or for functions, right? And this one, a hexagon. A hexagon is used for the flow, for the for loops. So if you have a for loop for an iterative process, I use this type of symbol. This cylinder, I use this cylinder for storing the database. It is a magnetic disk used for storage of database. Now let us see an example with respect to the algorithm, with respect to pseudocode, with respect to flowchart. So before we see, let us compare the does this mean? This is a sequence logic. This uses a sequence logic. You have begin, you have two different shapes, you get the program. Right? So here this is simply the flowchart where it comes in sequence. So after finishing that particular step, it goes to the second step and then goes to the third step. Then this is for selection logic. It uses selection logic. Selection logic is if the red light is on, I will be stopping my vehicle. If the green light is on, I will be taking my vehicle forward. Right? So here, if the question, if it is okay, true, then you have a statement. Else, you have a statement. Then when you use an if, you are supposed to use and because it's a pseudocode. That is what is represented in this diagram. You have a selection where the explained represented using diamond, and you have a set of procedure, and then if it is true, this will work out, or else this will work out. Then it comes out to the stop. So this is the comparison of pseudocode and flowchart. Now let us take an example to find the area and circumference of a circle. What is area of a circle? What is area of a circle? Pi r square. What is pi r square? What is the value of pi? 3.14. So 3.14 into r into r. So now what is the circumference of a circle? Formula for circumference of a circle? It is 2 pi r. 2 into 3.14 into r. Right? So now let us see an algorithm for finding the area and circumference of a circle. Step 1, because in our algorithm I am supposed to write in steps, right? Step 1, start. Step 2, read the radius of circle as r. Here I have written as REAR, this is REAR, it should be read radius of circle as r. Step 3, you are calculating the area and you are storing the value in the variable called area. Area equal to 3.14 into r into r. Step 4, you are calculating the circumference and you are storing the value of circumference in the variable called circumference. Circumference is equal to 2 into 3.14 into r, because the formula of circumference of a circle is 2 pi r, 2 into 3.14 into r. Then I am printing the area. Step 5, print area. Step 6, print circumference. Then any algorithm which I am going to have a start, I need to have a stop. So step 7 is stop. Now let us see how to write a pseudocode for this. Read REAR again. It should be spelled as READ. Read radius of the circle as r. Calculate area equal to 3.14 into r into r. Calculate circumference equal to 2 into 3.14 into r. You print the area, you print the circumference. And then here you can use begin main program, end main program. Right? Then let us see a flowchart for this area and circumference of a circle. Here in the flowchart you have start. I said the ellipse, it is used for the terminator, it is a terminator symbol which demarcates the start and stop. So the start is being given using this ellipse. Then this parallelogram gives the read, which is used to measure the, it is called as data input output symbol. Right? For inputting, for outputting, you use a parallelogram. So now I want to read the value of r. Where if you want to calculate the area of circumference, I need the radius of a circle, right? So I am reading the radius as r, which is being built within this parallelogram. And from this step to this step, you have an arrow bar, which is called as a control flow. It flows from the start, then the second step. So this is the control flow. The third step is said to be the procedure. I gave an example of C equal to A plus B. Here the example is said to be area of a circle, to find the area of a circle and to find the circumference of a circle. Where the area of a circle formula is said to be 3.14 into r into r. Circumference of a circle is said to be 2 into 3.14 into r. Right? So area equal to 3.14 into r into r. Circumference equal to 2 into 3.14 into r, which is being given in a rectangle, inside a rectangle. Then I am supposed to print the area and the circumference that has been calculated by using a procedure, right? So I am printing it. I am printing for input and output, you use a parallelogram symbol. For input and output, you use a parallelogram symbol. So here in input, you have taken parallelogram symbol, you have read the value of r. Here in output, you are using a parallelogram symbol, You are printing the area and circumference of a circle, right? Any algorithm, anything, it should have a start and stop. So now you stop it using an oval symbol, or it has an elliptical symbol, which is said to be a terminated symbol. So this is an example to demarcate between algorithm, pseudocode and flowchart. Now, next coming to the programming languages. What is a programming language? Any computer, it cannot understand the programming language. A computer basically is an idiot box. Whatever we give an input, it will work based on the input that we give, and it will produce an output supposing the logic is correct, right? So it has been coded with the help of programming languages. We have different kinds of programming languages. We have programming languages such as C, C++, Fortran, Pascal, Java, Python, so on and so forth. And we will be discussing more about this in the Python. Then, the last but not least, let us say how to solve a problem using algorithm. What is the way of having the algorithm problem solving? First of all, anything, if I have a problem, if I have an issue, what should I do? I need to understand the issue. I need to understand the problem. That is called understanding the problem. Then, I need to ascertain the capabilities of the computation device. See, I have a problem, right? And if I get a problem, first of all I need to understand, okay, what is this problem about? How to work out? And the second one is understanding the capabilities of computation device. Whether do I have such a kind of computer? Do I have a memory? Do I have the input and output values? Do I have the storage space, right? So that determines the computational device. Say for example, if I want to play a 3D game with my Pentium 3 machine or my Pentium 4 machine, which is a different age-old machines, where if I want to play a 3D game, say for example, if the game is between alpha 8 game, we will not be in a position to play, supposing we do not have my accelerator car or my 3D car, right? So it depends upon the computational device that is being worked on. Then the third point is about the exact or approximate solution. Say for example, again, if we want to find the square root of 3, what is the square root of 3? It is 1.732, you will be saying, but does it stop with 1.732? No, it goes on 1.732, 84765, and it goes on. So you get an approximate solution as 1.732, and you do it for a computation. Similarly, for area of circle, again the pi value, if you are going to give it as 22 by 7, does it stop at 3.14? No, it extends 3.14, 5, 6, 7, 8, 9, 2. So it goes on, right? So we make it an approximate solution as 3.14. Then the fourth point is about you should decide on appropriate data structure. What is the data structure? Whether to use list or whether to use record, or how it should be worked out, whether to use structure or unit, how it should be worked out. And the fifth point is about the method of specifying an algorithm. What is the methodology that I am going to adopt to work out an algorithm? That is about the method of specifying an algorithm. So the next point, sixth point, is about the proving the algorithm correctness. Whatever I do, is it correct? Is it logical? Is it validated? So the algorithm correctness has to be validated. Validation process has to be done over here. The seventh one is analyzing the algorithm. Whatever I write, I should analyze first whether it is okay, whether it is fine. Because in the initial first slide, what we saw is an algorithm, whatever is written, it should be precise, it should be unique, it should be finite, it should have an input, it should have an output, it should be a generic, right? So now again, I am concluding over here with whatever we saw in the first slide. I am concluding it in the last slide as you need to understand the problem, you need to ascertain the capabilities of the computational device, you need to have an exact and approximate solution, you need to decide on the appropriate data structure that is to be used, you need to specify the methods of an algorithm, you need to have the correctness of an algorithm, and the algorithm has to be analyzed. So this determines, if you have all these steps, you can solve any problem using algorithm. That is called as algorithmic problem solving. So this determines or this content. Thank you for giving me an opportunity. Thank you.